Now, we're going to look at some probability problems that we're going to face. And the first one here is, if we've got a family of 3 children, what's the probability there's at least one boy? Now, if there's at least one boy, like, there's two ways to do this question. Um, the first part describes the easy way. The at least one boy means if it's 3 boys, or 2 boys, or 1 boy. Now, if we look at our sample space for this, the only thing that hasn't been included is it's 3 girls. So the easy way to do this question is not by looking at the question that way, but the idea that all 7 there plus the 3 girls would be equal to 1 because they'd be complementary. So if I just take 1 minus the probability of 3 girls there, which is a half times a half times a half, then it'd be 1 minus 7/8, which is 1 minus 1/8, which is 7/8. So this is where this technique comes in handy. It's like you can do it with 3, but it's much easier than doing 7 different probabilities to just do 1 minus 1 probability. So be careful when you see that idea of at least 1. So because that one comes up a lot. The idea at least 1. We're going to use a complementary event. That's getting our complementary events in there. So we've got 2 coins are tossed in the sample space. We know the probability of 2 heads is a quarter. In any order, probably heads and tails is 2 quarters and 2 tails is a quarter. What's probably throwing at least 1 tail? So at least 1 tail is, well, everything except the idea of getting 2 heads. So it would give us 1 minus a half times a half, which is 3/4, which is not too hard to go, well, it's a quarter plus. So a quarter here plus the 2/4 is 3/4. That one's not too bad to do it that way. It's getting that idea about the least 1 situation. So we've got a bird which has a 1/12 of hatching a bird with white feathers. Bird lays 3 eggs. What's the probability of hatching exactly 1 bird with? So an exactly situation would be, well, it could be the first bird's white, the second bird's white, or the third bird's white, and the other 2 wouldn't be white. So we get 1/12 times 11/12 times 11/12, and then the same thing in a different order. So 3 lots of that gives us 121 on 576. Now, probably at least 1 bird with white feathers. Well, if we want at least 1, we can get all 3, we can get 2, or we can get only 1. Or we could look at a situation of 1 minus probability that none of them have white feathers. So again, that's much easier than to calculate all the other probabilities that could occur. And we do our calculation, put it in our calculator. We've got a class of 12 males and 15 females, and there's 7 males and 9 females in the class who play tennis. Students chosen at random. Find a female who doesn't play tennis. Well, out of that, there's 6 who don't play tennis out of the 27. Complete. A male tennis player? Well, there's 7 males that play tennis out of the 27, so there's our probability. So in the case of just getting our ideas right there. This time we've got 20 coins tossed. The probability that all comes up tails. Well, that'd be 1 half times a half times a half times a half. 20 times. So we'll leave it as 1 over 2 to the power of 20. Because 2 to the power of 20 is really large. So we won't bother writing it out. We'll just leave it like that. And that's okay. Probably this time we have n coins that are tossed. Well, again, all it is the half to the power of n. Because probably if they're all going to come up tails, well, they've got half times a half times a half, and that would occur n times, which gives us 1 on 2 to the power of n. This time, here's another one where our Venn diagram, because we've got 4,000 population in a town where 2,500 are descendants of Campbells and 1,900 descendants of Donalds, while 300 are not descendants of either clan. So what's the probability of descendant of both the Donald and Campbell? Well, there's our situation when we've doubled up. So we take our 300 out that were from neither. So it leaves us 3,700 minus, take that away from the sum of 2,500 and 1,900. That leaves us the 700 that must have been doubled up. So if it's 700 double up there, that's 1,800 that just come from the Campbell clan and 1,200 just come from the Donald clan. So what's the probability that you get both from Donald or Campbell? 700 out of the 4,000, which gives us the 7 on the 40. So it's about being able to get that number that we've doubled up on as we go through and do these types of problems.